Hello students, I hope that you are good, well and fine. And today we will be starting with inverse trigonometric function chapter 2 class 12th. Okay, so what we will be covering, let's see. So in upcoming lectures, what we will be covering basic concepts, a sine inverse function and the graph of a sine inverse function, and then cos inverse function, and then the graph of cos inverse function, then cosec inverse function, then the graph for it, then the sec inverse, tan inverse, graph for tan inverse, cot, graph of cot, and some example we will be doing in today's lecture. What we will be covering, mainly we will be covering these three things. The basic concepts you need to know before starting with ITF or the inverse trigonometric function, and then we will be getting what and how the sine inverse is defined, and where it is defined, the graph for it, how it looks like. Okay, let's move now. So basic concepts, what you need to know first of all about the functions. So the basic trigonometric functions: sine, cosine, tan, cot, sec and cosec. Okay, you must know their domains. Sine function domain is all real number and its range is -1 to 1. Okay, if you recall the graph, for sine graph, sine x graph is looks like what? A wave. Say a wave. Okay, like this. And the where it is 0, it is 0. So these 0, as you can see. Okay, so sine x is 0 when multiple of pi, multiples of pi. This means sine x is 0 for x is equals to some n pi, where n belongs to the integer. Okay, now this cos or the cosine, the domain is the same as the sine function, and the range is also same as the sine function, -1 to 1 closed interval. And the graph for it looks like what? Let's see. If you recall, if you do not remember, don't worry, you will see here. Okay, so cos graph starts with this. Okay, like this. Okay, so here it is 1 and here it is what? -1. Okay, so as say the cos, as the cos is a c means cut. If you make some sense out of it, cut means you are decreasing something. This means decrease. So as you can see, the graph is starts at here in decreasing form. Okay, but here as sine, the opposite of it, you can say the increase. It is increasing, but from here at 0 point, and it is decreasing from 1. Okay, and it is 0 when cos x is 0. Cos x is equals to 0 when x is what? The odd multiples of pi by 2. If you recall, this point is pi by 2, this point is minus pi by 2, and this will be what? This will be 3 pi by 2. Yes. Okay, so odd multiples of pi by 2. Okay, so n belongs to the set integer. Okay, what about the tangent function or the tan x? Tan x domain is, we know what? We know that tan x is equals to the ratio of 2 trigonometric function which is sine and cos, and we know that in mathematics the denominator must not be equals to 0. So cosec must not be equals to 0. So this means the domain will be any real number but except such x where the cosec is 0, and we know cosec is 0 where cosec is 0, x belongs to R, such that x is what? X is not equals to what? The odd multiples of pi by 2. So any R, set of all R such that x is equals to 2n plus 1 pi by 2, the set of all odd multiples of pi by 2, and we are eliminating such all real numbers. So this is will be my domain for 10x. So as you can see, x not from this set, you can say that. Okay, I hope that it is clear to you. Okay, so as if you try to simplify it, what you will get plus k pi. So take pi by 2 common, what you will get is 1 plus 2 k, and k is belongs to integer. As you can see, this thing and the thing I have wrote in this form is same. Okay, so don't confuse. Okay, now what? This will be my domain. Okay, and the range is what? The all real numbers. If you recall the graph for 10x will look like this. So at minus pi by 2 and pi by 2, say here at pi by 2, okay, as it gets near 0, this whole thing will be getting higher and higher. So this means it kept increasing at x value reach very near to pi by 2. This means the denominator becomes too small, and this means the whole fraction or this expression gets higher and higher, going to infinity. So your graph will look like at this point at increasing, and if you are going to at minus pi by 2, still it is going to the negative value, but it is now going to minus infinity. So from here you can get idea that what your graph look like. This, your graph will look like this. Okay, so 10 graph is this. Okay, now for cotangent, what do we mean by cotangent? Cotangent, cot x is equals to what? The ratio of cos x by sin x. You all know that cos x by sin x, or what you can say is 1 by 10x. Okay, so from this, cot x is equals to cos x by sin x, and we know the denominator cannot be equals to 0. So from this, what I can say is that the domain must be, domain is equals to any r, any real number, but not where set all of x belongs to r such that sin x is equals to 0. In other words, x is equals to what? The n multiples, the integer multiples of pi, where n belongs to the set of integer. So this will be my what? Domain. As you can see, x cannot be equals to the multiple of pi. So the domain will be all real number except this. Okay. What about the range? Range will be same as the 10. The graph will look like for this as, if you see, we cannot take this. So, and this is my 0, this is my pi, because at this point over here and at this point over here the denominator gets 0. So this means as sin x is at near 0, this means the value will be much higher, and for if the sin x, the x is near to pi, the value will be in negative and much lesser, going to minus infinity. So from here it is going to minus infinity, from here it is plus infinity. Okay, I hope that it is now clear to you. Now what? Now as you know, this will be what? The cos x is 0 at where? You all know, at pi by 2. So this will be at pi by 2 point. Okay. Okay. Now let's see for the secant. Secant is what? 1 by cos. So sec x is what? 1 by cos x. As we know that denominator cannot be equals to 0. So all real number except x from real numbers such that x is equals to the odd multiples of pi by 2. Yes. So this will be my domain, as, or in short, you can write that x, all real number except x cannot be equals to 2n plus 1 by pi by 2, or in other words, or what you can say is pi by 2 plus k pi. Yes, this is what you can say, not k, n. Okay, and this is what written over here. The domain is this, but the range will be all real numbers except this. Why? If you recall the graph for the cosecant function, it is quite easy to remember. Let me give you how you can easily recall the graph for secant function. So to draw the graph for secant, always make what? The cos graph. So always start with the cos graph. So this is your cos graph. Okay. Okay. And we know what? We know that here we cannot take these values. So this means at x is near to these points, the sec x will give output to either infinity or to the minus infinity. Okay. So okay, now what? Now just do nothing, just make parabolas like these. Okay, so the graph for sec x will be this easy to make. So as you can see, the range is from -1, the closed, here it is 1 and here it is -1. So the range is, as you can see, it covers minus infinity to -1 union, and it also covers 1 to infinity, 1 to infinity. As you can see, no values in between these -1 to 1 is covered. Okay, that's why the range will be this set. Okay, as you can see over here. Okay, now cosecant function. For cosecant function, what we know? We know cosec x is equals to 1 by sin x. Yes, 1 by sin x, and 1 by sin x, and we know that we cannot take denominator as 0. So the domain will be what? All real number except x belongs to the real number such that sin x is 0. We are going to exclude all such points where sin x is 0. Okay, so this means, in other words, if you try to see, the sin x is 0 when x is equals to, this set is x is equals to n pi, such that n belongs to the set of integers. This, so, or in short, you can write that x cannot be equals to n pi where n belongs to some integer. This will be my what? Domain. Okay, so this will be what? My domain. So domain will be x not equals to k pi, as k is any integer. Okay, what about the range? For range is same as this, as you can see over here. But can you recall the graph? Let me draw a graph for you so that you can get how we are going to draw with ease. Okay, so graph for cosec always start with sine. So please always make sine graph. Okay, as you saw in sec graph, we always start with cos graph. Okay, so in here we always start with sine graph. We know this is what 1 and this is what -1, and these points wherever the sign is 0, we cannot take these values. Why? Because this will make the denominator 0, and if denominator 0, it is undefined, not properly defined. Okay, and from this what I can say, as my x is near to 0, say, you can see the cosec will goes to what? Infinity, plus infinity. And if x is 0, but from this side, left side, now my cosec will be going to minus infinity. So from this side it is going to this plus infinity, and from this side, if x is near, then it is going to minus infinity. Okay, so this says that the graph will look like something this. Okay, so I hope that it is clear that how we drew the graph for cosec and sec. Okay, so as you can see, the range over here is as you can see, the graph covers only what part? Minus infinity to -1 union 1 to infinity part. That's it. Okay, so that's why the range is written as like this: minus infinity to -1 and 1 to infinity. These points are included in the range set. So that's it for these 6 functions about domain and ranges. Okay, so in order to start with ITF, one must know these basic things about these 6 trigonometric functions and their domains and range. Okay, let's move to next. And what must be known to us is we already saw that these are the sine function. Sine function is from r to -1 to 1. Cos is also from r to -1 to 1. Tan is r but not r. The domain is any real number but not real numbers which is equals to the pi by 2 odd multiples. Okay, and the range is whole r. Okay, and for this we already discussed. I'm not going to say them again. Okay, so I'm going to just move to next, so that we will start with the main thing, which is what? The ITF. Okay, so now starting with sine inverse function. So sine inverse function, so how we are going to define it. So, and when we define it, if you recall, first of all, before starting with this, it is inverse function. Can you recall something from inverse function? Inverse function exists when they, so inverse of an function exists only when, if the function we are talking about, if the function is what? 1 1 as well as onto, as well as what? Onto. So my function must be 1 1 and onto. If you recall 1 1, what do we mean by 1 1? 1 1 means if f of x1 is equals to f of x2, then x1 is equals to x2. For every x1 and x2 belongs to the domain of f. And second one is onto. Onto means range set is equals to the codomain set. Codomain set. Or in other words, every element in codomain set have what? Pre-image in the domain set, in the domain set. Okay, I hope that you recall these basic definitions. Okay, so now in order to define this sine inverse function, we need our function sine x to be 1 1 and onto. If you see the sine graph looks like this. Yes, if you perform what? Horizontal line test, as you can see, my horizontal line cuts the graph at 4 points, and if you produce it further line and produce the graph of sine x further, you will find out there are infinitely many points at this line cross the graph. So this means it is indeed not 1 1 in the whole real number. Okay, so but we need the inverse function. So in order to define this inverse function, what we need? Our function, our sine x function to be 1 1 and onto. Okay, so that's why we only define, so that's why that's the reason behind it. We define our sine inverse function from, to make sine x 1 1 and onto, we take a interval minus pi to pi. As you can see that my sine function in this interval, my sine function in this interval is 1 1 as well as onto, because sine function is what we are saying that it is defined. I am just taking the domain as this, and the range we all know that it is -1 to 1. Okay, so it is 1 1. If you can perform the horizontal line test, you always going to see that it cuts only at 1 point, and your range or the output will be same as this set -1 to 1 or the codomain set. So this means your what that if the function is defined like y is this, then only you can define your inverse function. Okay, so this and this interval, what we called it as principal value branch, whereas other intervals as range give different branch of this. Okay, I hope that it is quite clear to you. Please keep this term in mind, because many questions frame on this single term, principal value branch. Okay, so when we refer to the to the function sine inverse, we take it as the function whose domain is this, as sine function is this. If you recall in inverse function, if f is defined from a to b, and in inverse we know that f must be 1 1 and onto. If f defined from a to b, then its inverse is defined from where? B to a. Yes, b to a. Okay, so this means if sine is defined from this interval to this interval, this means that sine inverse function is defined from -1 to 1 to minus pi by 2 to pi by 2. Okay, so the domain for this sine inverse function is what? -1 to 1, and codomain is this, minus pi by 2 to pi by 2. Okay, so if you see that the value of, say, sine inverse of 1 by root 2. So sine inverse of 1 by root 2. As we know, sine inverse domain is -1 to 1 closed interval, and the range is minus pi by 2 to pi by 2. Find this value. What you will get? The pi by 4. Yes, because sine pi by 4 we all know is 1 by root 2. Okay, sine pi by 4. So sine inverse 1 by root 2 is equals to pi by 4. Okay, sine root 3 by 2 will be what? Pi by what? Pi by 3. Yes. Sine inverse 1 will be what? Pi by 2 indeed. And sine, say, sine 1 by 2 will be what? Pi by 6. Okay. Okay, and sine, sorry, we are talking about inverse. Sine inverse 0 will be what? Will be what? 0. Okay, 0. Okay, so now okay, so sine 0 is this. Okay, and sine inverse 1 by 2 is pi by 6. Okay, sine 1 by 2 is pi by 6. Sine 1 by root 2 is pi by 4, and then pi by 3 for this, and pi by 2 for this. And are there any other you can think of? We know the sine, we know what we know. We know sine 0 value. We know sine 30 value. 30 degree means pi by 6. What it is equals to? 1 by 2. Indeed, 1 by 2. And sine what? If you recall, the sine pi by 4 will be this. And for what? For sine, if you recall, pi by 3, which is what? This is equals to root 3 by 2. And for sine, say sine pi by what? Pi by 2 is equals to 1. That's it. Okay, so these are the simple values that you come up with. Okay, now from this point, can you plot the graph for sine inverse? Let's try to plot the graph. Okay, let's try. So my graph for sine inverse will be what? So okay, so like this. Okay, so sine inverse. What we know, the domain is from -1 to 1. This means -1 to 1. Okay, -1 to 1, and the range will be what? Say minus pi by 2 to pi by 2. Okay, now at 0 it is 0. Okay, at 0 it is 0. Okay, at 1 by 2, 1 by 2 means here at 1 by 2 it is what? Pi by 6. So we know this is 0. This is what? This is pi by 6. This is pi by 4, and this is pi by 3. Okay. Okay. Now, okay. And now this is half. Half means the pi by 6 value. Okay. At 1 it is pi by 2. At 1 it is this. At root 3 by 2. So root 3 will be somewhere here. It is what? At root 3 it is what? So pi by 3 value like this. Okay. So value like this. Okay. Now your pi by root now 1 by root 2 will be somewhere here, and this value is this. So as you know, your sine graph is like this. Then as you can see, your values, you can see this is your high, then low, okay, and then comes with here. So as you can see, your graph is coming like this. Yes, your graph is coming like this one. Yes, and the similar thing will happen for this, as we know. Okay. Okay, if you try to calculate for these values also. So what can you conclude from here? That your graph will something look like this, just by from these points. Okay. Now let's see the actual and the well presented graph for it. Okay. So we will see this point next. So first of all, the graph will look like this. As you can see, this is what, so let me use the red one. This is what we know the sine graph. So for the sine graph is this. In this interval minus pi by 2 to pi by 2, we know it is 1 1 and on 2. And the inverse graph is what? As you can see, the inverse graph is this. Yes, as you can see, this is my inverse graph. This is sine inverse, and this is what? Sine graph. Okay. And you can get your inverse function graph by just what? Just mirror your graph with respect to this y is equals to x line. So this y equals to x line. Plot the sine graph. So plotting on the sine graph and mirror your graph with respect to this y is equals to x line is you can easily see that this is while mirroring with respect to this line, you will get this, and for this part you will get this. As you can see, it is quite easy to get the sine inverse function graph using this way. Or the another way is this. The sine x graph is like this. Yes, this means this. Whenever you see such kind that you are going to left to right, then your graph will be like this. Your graph will be like down to up, like this. Okay, like this. From this you saw that your graph will look like this. Yes, so whenever you see this, you will automatically draw this. So left to right will be up to, sorry, down to up, down to up. Okay, so this I hope that you understood how the sine inverse graph will look like. Now let's come to this point. So from the definition of the inverse function, it follows that what? Sine inverse x will be x if that x is less than equals to 1. If we are talking in this domain, yes, because the domain for this is what? This set. Yes, the domain for this sine inverse function is this set. Whenever x is in between this, then the sine inverse sine x sine of sine inverse x will be x, and if sine x will be x if we are in what? Because we know what we know. Okay, we know if this, because sine inverse of this must be belongs to this, because it must satisfy the domain thing. So this means sine x must be less than equals to 1 but greater than equals to -1, and we know this happens when this happens, we know because x must belongs to pi by 2 to minus pi by 2. Yes, because the sine inverse is defined from -1 to 1 to the codomain is minus pi by 2 to pi by 2. Okay, and the sine function is defined from, it is from real numbers, what we will take from minus pi by 2 to pi by 2, because in order to get the inverse function we need it to be 1 1 as well as on 2. This means -1 to 1. Okay. Okay, so from this point what you can say, you can easily say that sine inverse of say pi by 2, not pi, sine inverse of 1 will be what? 1, and sine inverse of sine say pi by 2 will be what? Pi by 2. Okay, as you can easily evaluate it, what you will get this value as 1, and this value we know this is pi by 2. So just simply write pi by 2 over here. Okay, the main thing keep in mind is this, that this can only happen when x must satisfy this thing, and this can only happen when x must satisfy this thing. Okay, so that's it for today. We will be meeting into the next lecture. So thank you.